Hello, welcome to the course of Computer Networks. So today we are going to discuss about the data communication. In this class, we will discuss about the importance of data communication. Next, we will discuss about the few terms related to data communication. And then the type of signals and how to convert analog to digital signals and the data compression technique. So let's discuss about the importance of data communication. Here the data communication is a combination of ideas and approaches from physics, mathematics and electrical energy. Here the physics draws the ideas about electric current, light wave, radio waves and electromagnetic waves. Whereas the mathematics include theories and various form of analysis of data communication, and in electrical engineering we use different technologies that are developed for the data communication process. It means the data communication is a combination of physics, mathematics and electrical engineering to produce a signal that is transmitted from the information source to the destination. So this diagram is showing how the signal is transmitted from information source to the destination. So here the analog signal is generated by the information source, or it may be also generate the digital signal. Next, the source encoder convert the analog signal to the digital signal and then it is transmitted to the encryptor. Here the encryptor adds the code to protect the original signal from the outsider. Then it goes to the channel encoder. Here the channel encoder will add the techniques uh, to reduce the transmission error. After that, this signal goes to the multiplexer. Here the multiplexer will combine the signal that is coming from the different information source. It combines the signals and transmit over the same shared medium. Here then it goes to the modulator. Here this modulator will modulate the message signals over the high frequency carrier signal so that it can transmit to a longer distance. Then it transmit to the physical channel. The physical channel may be a wired channel or a wireless channel. Then it goes to the demodulator where the carrier signal is separated from the message signal, and if this message signal is sent to the demultiplexer. Here demultiplexer separate the signal that are combined at the multiplexer. So this separated the signal, and this separated signals goes to the channel decoder that will reduce the transmission error. Then decryptor, it will extract the code from the original message, and then at the source decoder it will decode the digital signal to the analog signal, and the analog signal will goes to the destination. So in this way the signal is transmitted from information source to the destination. Let's discuss about these devices one by one. So first one is the information source. Here a source of information can either be an analog or a digital, but here the important concept include the characteristic of a signal such as amplitude, frequency and phase. Here these signals are further classified in periodic and aperiodic signal. Next is source encoder and decoder. Here the digitized information is separated into digital form and transformed and converted to the other form. Here the main working of encoder and decoder is to convert the analog signal to digital and digital to the analog signal. Next is encryptor and decryptor. It is used to protect information and keep it the confidential. Here the encryptor is used at the transmission part and decryptor is used at the reception part. Next one is channel encoding and decoder. Here the channel encoder provide the channel coding that is used to detect and correct the transmission error. It includes methods to detect and limit error. These methods includes parity checking, checksum and cyclic redundancy codes. Next is multiplexer and demultiplexer. Here the multiplexing refers to the way information from multiple sources combined for transmission across a shared medium, and in demultiplexers these combined signals are separated and sent to the different destination. Then is modulator and demodulator. Here the modulation refers to the way EM waves are used to send information, that is the low frequency message signal is imposed over to the high frequency carrier signal and transmitted to a longer distance, and at demodulator this message signal is separated from the carrier signal. Then is physical channel and transmission. Here it includes transmission media and transmission mode. Here the transmission media is selected on the basis of high bandwidth, low electrical noise and interference, and high channel capacity. And transmission modes are selected from the serial mode and parallel mode. Next is the type of signal. There are two types of signal, that is analog signal and digital signal. The analog signal contain information which is translated into electrical pulses of varying amplitude, whereas in digital signal the translation of information is into binary format where each bit is representing the two distinct amplitude, that is 0 and 1. So this diagram is showing the analog and digital signal. So this is the analog signal that having an electric pulse of same amplitude, and this one is a digital signal. This high amplitude is depicting the 1 value and this 0 depicting the low value. Here these signals are further divided into periodic and aperiodic signal. Here aperiodic signals signals are the signal that repeats its pattern over a period of time. Here like this signal is a periodic signal, like it is repeating. This is the one wave and then it is repeating itself again. So this is a periodic signal. Aperiodic signals are a signal which doesn't repeat itself after a specific interval of a time. Next is the sine wave. Here the sine wave will have a 4 important characteristics of signal like frequency, amplitude, phase and the wavelength. So here this sine wave is depicting these 4 characteristics. The frequency, here the frequency defined as the number of oscillation per unit time. So the oscillations are like, this is the one oscillation that is ending here, next one oscillation is ending here. So this is depicting the oscillation of the frequency, that is depicting as the frequency. Next is amplitude. Amplitude is the difference between the maximum and minimum signal height. So this is depicting the amplitude. Next is phase. Here the phase of the wave is defined as the distance between the first zero crossing. So this is the first zero crossing and the point in this phase. So this one is the first phase and then it changed its phase here, then again it changed the phase here and then it changed the phase at here. So this is the phase of the wave. Next is wavelength. Wavelength define the length of a cycle as a signal propagate across a medium. So this is defining the wavelength. This high amplitude is defined as crest and low amplitude is defined as the trough. Next is the composite signal. Here a composite signal is a signal that is composed of other signals, or that is the combination of different signals. It is decomposed into set of simple sine waves, and a mathematical method discovered by a Fourier which allows a receiver to decompose a composite signal into a separate parts. Next, the encoding. The two methods are used to convert signal from analog to digital and digital to analog are pulse code modulation and delta modulation. In pulse code modulation, that is PCM, it refers to a technique where the level of an analog signal is measured repeatedly at fixed time interval and converted to the digital form. And in delta modulation, here it sends one quantization value followed by a string of values that give the difference between the previous value and the current value. It consists of a step such as sampling, quantizing and encoding. So PCM is a type of encoder decoder, whereas the delta modulation is a modulator. Here in PCM it is a expensive technology and delta modulation is a cheap technology. And here in delta modulation it has a simple structure as compared to the PCM. Next is the compressing signal. Here the data compression is a technique that reduces the number of bits required to represent the data. We reduce the number of bits so that the data can transmit data can be transmitted in a reduced time. So two methods are used, lossy and lossless. Here the lossy compression technique, here some information is lost during the compression. So this lossy compression is used with data such as image, a segment of video, a audio file. So the compression technique like JPG and MPEG-3 are used here in lossy compression. Next is lossless. Here the all information is retained during compression and here it preserves the original data without any change, and it is used for document or in any other situation where data must be preserved exactly. So these are the two type of compressing signals. So this is all about data communication. Thank you.